Good afternoon, everybody. Thank you for being here. My name is James. I hope you're in the right session. This is the Fundamentals of DAX Contexts. It's a little bit of a brain melt for a Thursday afternoon, but hopefully we're all here to have some fun and to learn a little bit of DAX. All right, before we begin, very quickly about me. My name is James. I am from Johannesburg in South Africa. And there are many things that I have many interests, like sport and musical theatre and stuff. But today I'm kind of really going to focus on one of my favorite things to do, which is wildlife. I'm very fortunate in South Africa to have exposure to amazing wildlife. And I use a lot of that in my demos today. Okay. We'll do that now. Sorry, that's... on questions. The session is quite tight in terms of time, so I will try and take questions, but I may answer them very quickly. If we do have questions, please put your hands up. I will take them, I will repeat them and try and answer, but we may struggle for time, so I'm going to not take too many. And then last thing is, please, the feedback forms. If you please fill out the feedback at the end of the session. I will show this link again. But it's very important for the speakers to get their feedback so that we know what we did right, what we did wrong, where it went straight over your head, and what sort of worked. So yeah, please, that would be very useful. Okay, let's have a look here. In this session, I'm going to try and do three things. We're going to look at the theory of DAX contexts. We're going to spend a little bit of time on theory, particularly of the concept of evaluation context, and obviously row context and filter context. We're then going to look at some visual examples in the presentation, in the slideshow themselves, and then we will explore those examples in Power BI. I see there are a couple of people who were in my session yesterday. There is quite a lot of overlap, but also quite a lot of new stuff, probably 50-50. So I hope that's okay. If you don't want to see 50% of the same stuff, don't maybe go find another session. But yeah, okay. Anyway, let's get heading off. What are we going to do in terms of how we're going to structure the session? Firstly, we're going to look at the theory of evaluation context. There's no demos or anything that I can show you here. This is a pure theory section. We're then going to move on and get familiar with our data set that I'm going to be using throughout the talk. And then we're going to look at various components that make up evaluation context. So filter context, row context, and using the calculate function to modify contexts. And then after that, we're going to look at one or two other things that we can do in terms of the context of a DAX evaluation context. So changing relationships and also context transitions. Now, context transitions is quite a complicated topic. We're going to look at it quite briefly, but I will show you an example. I will show you how to write, how to make your context transitions very clear in the way you write your queries, and hopefully that'll allow you to at least see what's going on. And then finally, we'll probably do examples all the way through, but we might do one or two right at the end. I'll just go to a couple more demos, and then questions if we have time. Okay. Right, so let's get kicked off. What is evaluation context? Okay. Really, the reason we need to understand evaluation context is as soon as we move into creating more complicated DAX measures or writing more complicated DAX at all, we need to understand the context in which it's being executed. Because DAX is intuitive, but it's not simple. It makes sense up to a point, and then suddenly we're not 100% sure what's going on anymore. And that's really where you've got to go back to the fundamentals and really understand what is the context in which this query is being executed, and why is it not doing what I'm expecting it to do. Okay, so the basic question that we have to ask about context is how is the same DAX formula, particular measures, but how is the same DAX formula able to return different results all over a report, all over a Excel spreadsheet, wherever we use it. You write one formula, and it comes up with a whole bunch of different results. And that is because of the evaluation context. That formula is then executed in a specific context over and over and over again. Okay, so each data point on your report has its own evaluation context. Sorry, this room is really weirdly shaped. I feel like if I look at my screen, I'm not looking at any of you. But anyway, okay, I'm going to try here. So there are two things that make up the evaluation context. We have the filter context, and we have the row context, okay? These are two very distinct things. They are not the same, okay? And they, in every situation where you have an evaluation context, you have both of these things. You always have both row context and filter context. We'll look at theory about them individually a little bit later, okay? But in every point, we have both of these things being applied at the same time. Okay, for now, the only theory we need to know is that the filter context filters. So the filter context decides what data we are going to run our query over, and the row context iterates, which means the row context goes over every row in that data set that we've now chosen, and it performs some sort of operation and brings back a result, okay? This filter context filters, row context iterates, that comes straight out of The Definitive Guide to DAX by Marco and Alberto. And if your book is called The Definitive Guide to Anything, you know it must be right. Okay, so I feel nothing about putting this straight onto a slide and saying this is how it works. Okay, so the corollary to the rule is that filter context does not have anything to do with the iteration over the rows, and row context does not have anything to do with the filtering of the rows. We will learn later about context transition, which is where the row context introduces a new filter context, but the row context itself is still not doing the filtering. The row context is introducing an additional filter context, and so it's happening like that. And for our purposes, we can always think of it that the filter context happens first, so we filter down to our data set, and then we do the iteration, okay? Especially for now, maybe a little bit later we'll see one or two examples where that's not true, but for now, think of it like that. Filter context gets us the right data set, row context goes over that data set, brings back results. Okay, so back to our theory. There are two contexts. They are different from each other, but in every execution we have both of these contexts present. And then every single individual value in any output format, whether it's Power BI, whether it's a cell in Excel, anything, it always has its own evaluation context. And that's something that's really important to get your head around. And I'm going to show you that in visual way in a second. Okay, so let's quickly have a quick look at our data set that we're going to use for the rest of this talk. Okay, it's a really boring table when you look at it like that. It's a lot more interesting if we look at it like this, which is a series of 12 photographs. And these photographs have a bunch of attributes. Okay, we have things like what is the name of the photograph, what is the animal in the photograph, what is the subcategory. That's just, I need to use that to show you relationships a bit later. When did I take the photograph? What kind of photograph is it? Is it a portrait or a close-up or a group photograph? What is the color? What is the background color? The ratings, and how many animals are in the photograph. It's a very basic data set, but for me, it works nicely for you to be able to see what's going on here if we know what it actually looks like. Okay, so in terms of a Power BI model, this is exactly what it looks like. It's a very well-defined star schema. We have an animal dimension on one side, we've got a subcategory dimension on the other side, and our fact table in the middle, okay? So one-to-many relationships, all the things that we're supposed to do for a modeling. Okay. So what kind of questions are we likely to ask over this data set? Well, the first and most obvious is how many photographs? How many photographs per time of day? How many photographs of per animal, et cetera, et cetera. The next thing, what total number of animals are across all the photographs? Okay. What's the average subject rating? What's the highest background rating? All these kinds of things we can ask. Now, all of these are very simple. We don't have to spend much time. I'm sure all of you would know how to write these measures immediately. Count the rows of the photo table, sum up the number of subjects column, average out the subject rating column, or bring us back the max of a background rating column. So a couple of very, very simple measures that we will use to explain various concepts. So our first important concept is filter context, okay? The filter context is, as I said earlier, it determines the underlying data set on which a calculation takes place, okay? So we've got our model, but on a specific calculation to bring back one result, whether it's on a graph, whether it's on a chart, whether it's in a table, we need to know the underlying data set for that specific calculation, okay? So if I have no filters on my data set, and I try some of these measures that we're talking about, how many images do we have? Well, we count them, 12. How many total subjects do we have? We get the column that we need to sum up, and we sum up the values in that column, bring back 45, okay? The same, all of these, we don't actually have to spend any time looking at them. This is, I hope, is fairly intuitive, and everyone kind of understands what's going on here, okay? So what can change the filter context under which an evaluation happens? There are a couple of things. Firstly, we can have filters. On our report, filters being externally applied on the right-hand side of when you're building a report. You know, it says here, page level filters, visual level filters, book level filters, etc. Okay? Obviously, those affect the data set that's being filtered. And slices on our report. So the front end where users can choose to look at a specific category of data at one point, slices will also influence it. Now, I've put these two together because for all intents and purposes, slices and filters are exactly the same thing, okay? So what happens, here's a simple example of that. Here we've got some photographs, morning, afternoon, evening, and night. If I were to look at the right-hand side of my report and I had the filters and I chose to show only afternoon or morning, what would happen? Well, our data set changes. We look at only those 9 photos, and then it brings back a result of 9, okay? So that's the filter context. And very similarly, if we had exactly the same thing, we had a slicer on our report, and we chose to slice by afternoon and morning only with a multi-select slicer, does exactly the same thing. First, filters down the data set, gets the list of values, there it is, gets the list of values, adds up, and brings us back a result. Okay, so that is the filter context in action. Very, very simply, we're going to go into it in a second, more detailed, but that is what filter context looks like. Okay, so what else can now influence filter context? Well, within our visuals, we have multiple filter contexts at all times. Remember I said at the beginning, every single data point has its own evaluation context. So if you have a graph that has an axis, a legend, and details on it, you are going to have multiple filter contexts present in that graph at all times. Let's have a look. What does that mean? Here we go. I have a graph at the bottom right over here. Basically, it's the count of photographs per color, okay? I've put the colors on the photograph, so it's pretty easy for us to see what's actually going on there. But when we build this graph, what actually happens in Power BI, or in the engine, not in Power BI, in the engine that calculates it? The first thing that happens is we try and calculate our first point. So we calculate gold, for instance. So we go to gold, and we introduce a filter context. So we filter our data set down to all the gold rows only. Then we perform our row context or our operation, bring back a result, 3. Then we move on to the next one, and we filter, and then we calculate, filter and calculate, filter and calculate. So we do this over and over again, repeatedly, in terms of how we calculate these points. What that means is we don't take our entire data set and go, oh, we're splitting this up, and we create various split it up and then assign it into groups or anything. It's not like that. Every single data point is calculated as its own calculation, and that's where the filter context comes in. Okay, so we're going to pop through all of these. Okay, so one of the ways we can see that happens is if we were to show that same data on a table rather than on a graph, because we now have before we had 7 colors, so we had 7 data points in 7 contexts. Now we have 8 rows because we also have a total row, okay? And the total row is not a sum of all of the other contexts. It's not a sum of the values that have been put on the visual. It is its very own evaluation context. So for that row, the filter context is bring me back all photographs, perform my operation, and bring me back a result. So instead of having 7 filter contexts, we now have 8 filter contexts or evaluation contexts and 8 different results. Now, if you dig deep into sort of query optimizer and the text and all of that, you may see that it doesn't pass 8 queries, it passes 1 or 2 queries into the engine. Yes, that is true, but but that is because of the engine optimizer. It's not because this theory does not hold true. It's still doing exactly that in the calculation. Okay, so the last thing that can influence filter context for now is external visuals. So if I have my average score of 3.42, and then I click on the evening axis of the graph, or the category of the graph, it will then create, again, a filter context. It will, and possibly influence another visual like a card, okay? So I click on something, it introduces another filter context which only applies to the card in this case, and that's what we get our calculation from. Okay, is there anyone who doesn't feel comfortable with filter context? Anyone have any questions about filter context that we need to talk about? No? Good. Excellent. Sorry, I'm going quite fast. So let's do a quick recap, mainly of the theory. Every single data point, this is the most important thing. If you take only one thing, just remember this. Every single data point is calculated within its own filter context. Okay? Total calculations have their own explicit filter context. Filter context respects explicit relationships. So when I didn't show you an example, but if I were to bring the categories from a dimension table and the measures from my fact table, the relationship would be respected. Otherwise, the model wouldn't work the way we wanted it to. Okay, so that's important to keep doing. Filter context is cumulative. What does this mean? Well, when you filter context, unless explicitly you do something to make it not do this, will always keep on adding. So if you're looking at a graph that has, or let's say a matrix that has animal, time of day, and your calculations, each filter context is animal and time of day, et cetera, et cetera. So it's not an or thing, it's an and. It goes down to the smallest set of data to make up a specific point. Okay? The filter context is evaluated first, as I said just now, and this is how one formula can bring back many results. Okay? So that's really the lowdown, the skinny on filter context. Okay? Understanding explicit filter context is the first step towards mastering DAX. So why I say that is because whenever you have a problem in DAX, the first thing you do, and I don't know if any of you have ever watched Marco's advanced videos or any of his videos, one of the things he loves to do is draw a circle and say, what is the filter context? And he says, oh, it's this brand, this date, this value, this color type of thing, so that you can visualize what is the data set that I should be working with or starting with. And then from there, you can understand what's actually happening, because now you've introduced a shift or an expand or a remove filters or a keep filters or any of those things, because understanding the explicit filter context gives you the ability to then try and dig into what's going on underneath with your actual formula where you are modifying that context. Okay, let's talk about row context. Sorry, let me have a sip of water and then let's talk about row context. Okay, row context. Well, before we talk about row context, let's talk about something that doesn't work. If we want to create some sort of measure for this for our photographs where we say, hey, we're going to get an overall photograph rating, and it's 2 times the subject rating plus the background rating, something like that. It's this weird calculation that we're doing. Okay? Based on what we know when we start DAX, the first thing we might try is something like that. Okay? And unfortunately, as you can see on the slide, this won't work. Okay? The reason for that is that the average function expects a column, and we are not passing in a column, we're passing in an expression. Okay? Now, we have to understand the row context in which our operator happens. Now, row context is always present. I said that earlier. Remember, I said that row context is evaluated in every data set. But certain functions in DAX don't allow you to do something like an expression in them. They expect a column, because that's a wrapper for a specific way that you would calculate the average. But whenever we calculate anything, we have to go over every row and count it. Think about if you were writing something in C# or in QBasic or whatever language you initially learned to program in. If you had 10 rows in an array and you needed to sum up the total of them and bring back a result, and you had to do it, how would you do it? The only way you can do it is you create a variable, and you say for each row, add this to that variable and go there. It's not a batch process, it's an iterative process like most programming. So that is exactly what happens in DAX 2. We have to have this iterative process where it goes over each row and performs the function that we've told it to do, okay? But we only explicitly see a row context in 2 scenarios. The one is when we create a calculated column, and the second one is when we compute an expression inside an iteration. Okay, so when I say, why do I say we only explicitly see it? Because that is the only time where it really is clear to us that this is what's going on. All of the rest of the time, the row context is actually kind of hidden behind a whole bunch of things. Now, if you think about when we create a calculated column, there is only one way it can do this. For every row in your data set, it's going to take your calculated column, whatever formula you put in your calculated column, and it's going to add it up one at a time. And it's going to store that value in your model, and that is the row context. That is where it creates an explicit row context to do that. It knows which row it's on at the time because it needs to get this value and that value and this value from the row to perform the calculation. So it does the next one, does the next one. That's the iteration. The other one is when we compute an expression inside an iteration in a formula that we've written, okay? And the reason we need that is because DAX works on column store technology. Now, we don't want to really go too deep into that theory, but column store technology means your data is actually stored in columns. It's not stored in rows. So it's not like in Excel where you can just be like this plus this is that, this plus this is that. Underlying that, the engine has to do a whole bunch of other work to work out the iteration that it's going through. So that's why we have these iterative functions. So let's look at an example. It's probably easier to understand if we see an example. So here we've got our overall rating that I just talked about, okay? So there are 2 ways we can do this. Either we create a calculated column, which means at load time, what's going to happen is that, sorry, I've got a different formula here. I just remembered that I didn't change this. But, okay, so we're going, it's only 1 plus 1. There's no 2 times anything here. Okay, so it's just photo plus photo, rating plus rating. So all it's going to do there is it's first going to create a, oh, why did it not show that? Sorry. Oh, okay. So I don't know why my slides are not doing what I wanted them to do. Let's go back there. Sorry. So in this case, it would go through every single row, and it would actually add them up. So you'd get 5, 8, 6, et cetera, et cetera. Sorry, I thought I had little visuals that actually showed this. But so that would be your iterator. It would go through each row, it would perform that calculation, store a value, store it in your model, okay? Then you could, because you now have a column, you can now pass it to the average function, which we know expects a column, and it will work correctly as expected, okay? The drawback to this method, of course, is that if you have a very big model and you're adding an extra column, you're adding a lot of space to your model for something that's really quite simple. It might be something that you only use on one report page that only gets viewed once a year. Why do we need to make our model of a 100 million row model so much bigger to deal with that specific problem? So there is a better way for us to do it in DAX, which is to use an iterator function. And what happens in the iterator function is that we write it like this. We use the average x function, the x indicating the explicit iterator, okay? And the arguments of the average x or any of the iterator functions are firstly the table over which you wish to iterate, okay? And then the expression which you wish to calculate over that iteration, okay? So we go through every row of the photo table, perform this operation, and then once you've got all of those, average out that row set, column set. Okay, so that's exactly what would happen here. We would get 5, then 8, then 6, and this one would actually go through it all in memory, create all of those values, and then perform the average. Bring it back, and that would be the result that would be displayed. Okay, so row context actually is really simple. If we think about it, it goes through each row, it does what you tell it to do, and it brings back a result. But it's important to know that it's different from the filter context, and it has a different function. Okay, and it's also important to know that we can, because we know what row we're in, once we introduce a row context, we can use that row to introduce something else, and we'll talk about that just now. Okay. So the calculate function is probably the most powerful thing within DAX, because what the calculate function does is it calculate a measure, and then the only arguments you can pass it are a filter or a modifier that you a filter context under which you want this measure to be calculated. Okay, so the calculate function allows us to modify the filter context of a formula. What kind of modifications can we do? We can reduce the filter by adding additional filters. That sounds kind of weird. We reduce by adding, but if we think about it, it makes sense. We reduce the filter context. We make our data set smaller because we add more filters to that data set, okay? And the common ways we will do that is by actually using the filter function in DAX, okay? We can also expand our filter context by removing some of the filters. So if I want to, for instance, calculate a subtotal or a total and then get a percentage, I need to remove a specific filter, get my whole value, and perform a divide or something to get that. Okay, we'll look at an example there. We use the all or the remove filters. There's multiple ways we can do that. And then the third thing we can do is we can change the filter context by altering the filters. And there are lots of different ways. So I think this one, we have got a visual example here, and then we'll pop into Power BI. So how many black photos, sorry, maybe it should be, how many photos of black animals have we got in our data set? So all we're doing here is basically we're saying, calculate the number of photos. Number of photos is a measure that we've seen over and over again already. But introduce this filter. We only want to see the photos where the primary subject color is black. Okay? So this might be something that you need to do. Someone says to you, hey, we want to create this black and white photo book, but we need to know which photos will work well in the black and white photograph, so we only want to see black animals in these photos. Okay? So now we've got our data set. If we just think about what's going to happen there, we're going to bring back the answer of 2. That's pretty clear, right? We're putting in a filter that says, bring back only the animals where the primary color is black. Okay? And that will do 2. But we haven't influenced that filter by a visual or by a slicer or something like that. This is within the measure itself. So no matter what we put there, it's always going to bring back that result if we haven't got any other filters present at the time. Okay? So What happens if we have other external filters? So now, let's say I'd filtered down to maybe, if we go back to our data set here, and I'd said, I only want to see the birds that are black, okay? It's quite clear that the two animals here that are black are zebra and wild dog. Those are not birds. So what would happen there? We would actually bring back a result of 0, okay? So first filter down to all the birds, then filter down to all the black photographs, bring back a result. Okay, so from a theory point of view, the filter context, the original filter context is respected unless it's explicitly overwritten. Okay, so this is the first kind of complicated concept that we're talking about. So if I've got normal filter contexts that I'd already been working on, they would all be respected unless it was explicitly overwritten. Now, how do I override a filter context? Well, I introduce a filter in my measure on the same column that the filter is already, the external filter is already there. Okay? So, so before we go there, let's have a look at this as an example. We need this one here, SQL Bits 2024. And we are going to look at the Calculate tab. And let me go to my measures table. What have I done wrong here? So I've got 4 measures on my table. So on my table here, I don't know if you can, is it sort of clearish? I've got basically, on my axes, I've got mammals versus birds. Sorry, my Zoomit is not working very well today. But I've got mammals versus birds, and the measure that we're interested in is the purple measure, which is the last one here, there, and here it's actually this blank space here, which is 0. Okay? So when I look at my number of black animals, that is what's happening there. But what would happen if I were to put this, let's put it on a table, which is a bit clearer. So let's put it on the table. So here you've got your example, and I can probably expand that. Here you can see now that I've got one black photo of grazing mammals, which is the zebra, one black mammal of predator mammals, which are the wild dogs, and that. Now, let me take off some of those category, subcategory, and let's put on instead the actual color. So, photo, primary subject color, put it onto my, primary subject color, put it on there. Now if you look at the number of black photos column, now I've got something really weird going on here, because now it's telling me that where my primary subject color is gold, I've got 2 photos where the primary subject color is black. And where I've got where my primary subject color is lilac, I've got 2 black photos. I only have 1 photo where the primary subject color. Why is that happening? And this is because I have explicitly overridden the filter context. So my filter context to calculate that the number of black photographs, if we look at it, it's this measure over here. And if we expand it, we make it nice and big. Can you see that? Basically, all I've done there is I say photo primary subject color equals black. When I do this, when I explicitly put a filter context inside my measure, it overrides all other external elements that may be affecting that specific column. So in this case, because I put it on a specific column, it will do that. Okay. So, and the reason for that is that what actually happens here is that it'll create a filter table. Oh man, James, you pressed the wrong button, sorry. This context hides, or the syntax hides what's actually going on. What it'll actually do is it'll filter the photo table, okay? And it will say, remove filters on the column, primary subject color, and then bring back, and then the last thing, would be to bring back that photo color. So that's what actually happens in the underlying calculation, because it says, ignore what filters are coming in from anywhere else on that column. Just use this filter that I've told you about. And that would be why you see this context of, regardless of what color I put on there, I'm always getting 2, because it's overwriting that gold with black. Okay, does that make sense? Just a couple of other things. Let's look at a couple of the other examples I kind of mentioned. This formula here, number of all photographs. Calculate number of photographs, all photo. That means remove all filters from the photo table. Remove all filters from the table, and then count the number of photos. So that would be always bring back the same result. Always bring back the same result, because I've taken it off the whole photo table. You could also say, remove all something like primary subject color here. Okay. Now it will remove any filter on the primary subject color, but it will respect all the other filters that are coming in from that point. Okay, so this is where DAX starts to get really powerful. You can now we're manipulating the context, and we're doing different things with our data. Okay, so let's look at, is there anything else on this specific screen we need to look at? Oh, number of photos, all categories. So this will be an example of where I've actually done that. Over here, number of photos, all categories. So what am I saying here? Remove the category, the filter on the category column, and calculate all photos. So let's look at what that actually means. Here it is here. No, it's not good on that. It's not good on that specific visual. So let's put a couple of other things on here. Where's my photo table? Name. So if we put that on there, and then we take the color off, I'm sorry, I'm overwriting my own filter context there. That's silly. I want to do, what have I done? Oh, here we go. So here, what I've got is I've split my animals and my birds, or my mammals and my birds. You can see that I've got number of photos 8 and 4. Number of photos, all categories, 12 now, because remember that category, mammals and birds, that is on the same table as subcategory. So I've removed that filter up to, and now I'm getting a full count. Now I'm getting a full count of all categories, because even though there are only 8 underlying rows, it counts 12 because it removes the filter context and applies its own filter context. Okay, let's go back to our slideshow and carry on to the next. Okay, we've done that. We've done some demos. Okay, so some of the other things we can do with DAX is we can modify relationships. Okay, so in this case, on my animal table, I have a class field, which tells you what kind of animal or what class of animal we're talking about. We only have 4 classes overall. It's a one-to-many relationship. If I try and count how many distinct animal classes I have, okay, I will always bring back the result of 4. What happens if I then filter down to a specific set of photographs? So let's take all the scene photographs, okay? I think that's the one I do here. So if I look at all the scene photographs, there's only one photograph, right? How many distinct animal classes can I have for one photograph? Only one. What is the answer going to be if I execute this query? 4. Why is it going to be 4? Because filtering that table doesn't filter this table because of the relationship. Okay? The relationship goes in that direction. It does not come back in this direction. If for this specific calculation, whatever I want to call it, I need to do that. Oh, sorry, I did portraits, not portrait photographs. So I've got four portrait photographs. 3 of them are of birds. I hope you can see that. And 1 is of a lion. And there, if I calculated it, I would have that problem that we talked about. So now what we have to do is we have to introduce a filter modifier or a relationship modifier, and we're using the cross filter one in this example. And what does that say we do? We do the distinct count as we were doing before, but instead of using the relationship in the model, we introduce artificially a relationship between animal key and photo key in both directions. That both keyword at the end means we're using the relationship in both directions. So what happens there? We now introduce a model in this way, so when we filter down records on our left-hand table, it also filters down that table, which only brings back 2, which is our expected result. Okay, so that's the context now. So we had a filter context on our left-hand table, and we're now propagating in a relationship to make sure that that filter context is being propagated through a one-directional relationship in the opposite direction and bringing back a result. Okay, there are a couple of different ways we can do these relationship modifiers. We can get related columns from another table. We can get a related table and perform a bunch of, we can perform a summarize or a row count or things like that over an entire table. We can use a relationship, so we can essentially, this is when we have multiple relationships, inactive relationships, role-playing dimensions. We can say, hey, for this specific calculation, I want to use the relationship between the primary subject color and the color table, but for that other calculation, I want to use background color and the color table. You know, those two things will talk to the same dimension table, so we need to be able to specify which relationship we're talking about. And then the cross filter, which is the one we looked at, which specifies the direction in which the cross filter should take place. Okay, how much time do I have? Sorry.
You have got 9 minutes.
9 minutes, okay. 8 minutes, okay. So we're going to show you quickly an example of that. So modifying relationships, here we are. Number of photographs and number of distinct animal classes. So you can see that in this visual, I split up my photos. This is not a great visual. Sorry. Let's just take these measures off to start with. Okay, so we start with the number of actual photos. And if we go down a bit, so we've got 4 photos of type group, 4 photos of type portrait, 3 photos of type close-up, 1 photo of type scene. Okay, if we add on our simple measure, which is called number of distinct animal classes simple, which is basically the immediate, the one we started with. If we, so the first one I showed you on the slides, if I now add that, you can see that even for a group with only 1 photograph, I'm bringing back the same value of 4 animal classes, okay, which is clearly wrong. So we replace it with that other measure that I showed you in the details, which is this one. So we put that one on the visual. Take this one off, we put that one on. And you can see that my group photos are 2 classes of animal, my portrait photos 2 classes of animal, my close-up 2 classes, and my scene photos 1, okay? So that is that's how we can modify relationships. Let's pop into the last part, context transitions. Okay, the reason I use this photograph to introduce this slide is because I was trying to take a photograph of this Inyala, and my camera kept on focusing on the birds that were flying past it. You can kind of see them in this photograph. And it could not work out what the subject was. So it was trying to change the context, and that always that's why I just put it here. So a context transition is using the current row context to create a new filter context, okay? So that's quite difficult to talk about, so let's look at an example. Now, this is a bit of a contrived example because, well, there's not really a lot in my data set that lends itself to a context transition. But what I'm trying to do here is I'm trying to create a measure that says, if I look at the number of animals in a photograph, okay, tell me how many photos there are that have the same or larger number of animals in my data set. Okay, does that make sense? So here's a photo of one animal, so we know that 12 photos are gonna have one or more photos in that. Okay, if I look at a photograph, I think the biggest one in my set has 14 animals. It'll be only itself. So how does this measure work? Well, we are going to do a sum x because we're going to sum them up over the photo table. So we're going to go first through the photo table. We then introduce, and this is where it becomes a little bit easier to see the row context, var my number of subjects equals, on the current row we are on, how many subjects are in the photograph. And then what do I want to do? I want to return a calculate of the count rows of the photo table. So you can see I'm going back to my table. I'm removing all filters, so I'm saying all rows in the photo table, and then I'm saying where the number of subjects is greater than or equal to my number of subjects. Okay, so if we go back into our demo, and we look at context transitions, and we put the name of the photograph on our table. Whoopsie, sorry. Name of our photograph on our table here, and then hopefully, why is it not? Okay, one more time. Add the name, put it first. There we go. Okay, so you can see that for all of my photos that have only one subject, our data set is now saying, okay, there are 12 photos in my data set with a greater or equal than number of subjects to that. Then we've got our B-eaters. So this one has 2 subjects, and it's saying we have 5 photos, 4, 3, 3, 1. So do we understand what's going on here? It's using this context, this value here, to now create a new filter context, which is to say filter now my entire data set by this context, look for all photographs that have that number or more subjects, and then sum them up and bring back a result, okay? At this point, it's pretty easy, but when you start getting complicated results is when I take that name back off here. How does that work? What do we think, what is going on here? Well, what that's actually saying is that, remember, for my row context, it says for the number of subjects, iterate through each row in my data set. There are 7 different photos that only have one animal in them. So for each one of those, it'll bring back the example of 12, the answer of 12, should I say. And that in total will bring back 84, because it'll go 7 times 12, 84. Okay? So this is kind of counterintuitive, because but it does show that it works on the row context. It has nothing to do with this visual. It has to do with that value within my data set, okay? And then if we do something like, let's just put the animal, so let's go back to how we had it, which is with the name on. I'm going to put the animal and the name of the photograph on this thing here. So let's go name, top, animal, over there. Okay, so here we've got our 12 photographs. If I were to now, you can see I've got a couple of photographs with lion. Okay, so there's 2 photographs with lion as the animal. If I were to now take the name of the photograph off, and they both have 12. If I were to take the name of the photograph off, we would expect on our lion to say 24, even if we took the number of subjects record off as well, okay? So, sorry, my presenting tool is going, is about to go flat, but I can't get to it now. Okay, but anyway, I could take that number of subjects context out of the way, and it would still work. Okay, right, I think that is pretty much the sum total of everything. Let's go back there. So we've gone through that. Yeah, basically I've got 1 minute for questions. Sorry, I was a bit tight, but does anyone have any questions? Yes, sir.
So you showed us initially the average function, which didn't quite do what we wanted in the context, and then you showed us average x, which was able to do what we wanted. What's the point of average, given that average x doesn't do what we wanted?
So the point of, oh, sorry, the question is, I showed you earlier the average function, which didn't do what we wanted it to. Then I showed you the average x function, which allows us to do what we wanted to do. What is the point of having an average function if it's so inflexible? And really, the point is that a lot of the time when people are doing an average, they will be doing an average over one column, and that the way we write that function is more intuitive to both SQL users and to Excel users. So DAX, in a way, is a victim of its own success here because they have the whole, yesterday I had a slide that said 5 minutes to wow, 5 months till what the, you know. So, and that's exactly what it is, because when you start, you can do these things so easily because they're all simple. And then as soon as you try to do something slightly more difficult, you have to learn a whole new context or a whole new formula, function, style. But the reality is that 80% or maybe more of all users may never go further than using simple sums, simple averages, etc. So the authors and the workers, the people who actually designed the language, have given us that option to make it easy and explicit and to look like Excel. Really, that's the real answer. It looks like Excel. Average, column, boom. All right. I'll take one more question. But please, if you need to go, please go. Please do remember the feedback. Please remember the feedback forms. The time is officially up. So if anyone has a question, you can come and ask me here. Thank you.